The recording should be turned on. So we were talking about the Terraform. So Terraform is infrastructure as a code tool and infrastructure on any cloud basically. Now, meaning of any cloud is that you can launch the infra on Amazon AWS, Azure, which is by Microsoft, and GCP, which is by Google, or any other cloud. Because in Terraform, it's an open source tool. You can create your modules that can be used for any cloud platform, and you can launch the infra directly. And what I mean by infra, it's not only EC2, you can do anything on AWS using Terraform. But when it comes to specifically on AWS, we have one more tool which is similar infrastructure as a code tool, and the name of that tool is Cloud Formation. Now, if we talk about the like which tool is more easy, if we compare both of the tools, Terraform is for any cloud operating system and sorry, any cloud platform. But when it comes to the Cloud Formation is only for AWS. It's dedicated to AWS, no other platform, because it's a service of AWS where you can directly place your code and you can execute that, the infra will be launched. And when we talk about which tool is more easy, like easy to write, definitely Cloud Formation will be more easy to write because only AWS can understand it. So that's why we have more refined, you can say, structure provided by AWS. You just have to provide the information, basic information, and the resource will be launched. So when we talk about the difference between these tools, I have downloaded few images here. Let me check those images. Hope those images are here. Here is the comparison of, no, this is the Ansible one. Here is the comparison of Terraform and the Cloud Formation. Okay, so here are a few criterias. On the basis of criterias, this is the comparison. The first one is the scope. When it comes to the scope, as I said, told you, the Terraform is not only for AWS, it can work with the, like, it's a comparatively faster supporting new AWS features. Like whenever there is a new feature to AWS, the Terraform is faster in that. Why? Because it's an open source tool. And lots of people are working in the open source projects. They are developing modules daily. And when it comes to the modules, you will find many, many modules on Terraform. Even you can't count the number of modules. Millions of modules can be there for Terraform only. Okay, somebody, yeah,
Yeah, it's me. Can you
yes.
talk more about how open source contribution works? For example, let's say you understand about one of the AWS service which is newly launched, and now you want it to be part of Terraform. So, like, how would you go ahead to contribute to the code?
You mean like how open source works, the flow of open
Yeah,
source. Okay,
yeah,
so what happens, for example, I'm a coder, right? And I work on Python programming language. So Python is also an open source programming language, right? So one day when I was working on Python, I was working on my own project, and I thought, like, I'm using few functions, and I thought if this function was available for the world, then people will feel easy to do their work, right? That can solve many problems. So what I did, I just send my code to the python.org. Now, what will happen there? They will you have to send your code to them. First of all, before directly sending your code to them, you have to share your code over the GitHub. Okay. After sharing your code to the GitHub, the code quality should be great. Great means absolutely great. You have to follow structure of the code quality. Structure means the styling. Okay, the styling of the code should be great. The syntax, basically syntax doesn't comes in the code quality. The styling, the number of loops, the conditional statements, everything should be perfect. It should look like this is a perfect written code by someone who is very very experienced in this language. After that, when your code becomes popular, like lots of people will be using your repository, your repository will be getting lots of hits. And after that, you can send your code to the python.org or any community who works on the open source. They will pick your code, they will test your code. If they find your code is perfect and there is no vulnerability in your code, then they will add your code in their future upcoming modules. And after that, if somebody is using Python or any other language, they can easily pull your modules for the Python, like if they are using Python. Similarly, the same concept works with Terraform. In the Terraform, like the organization where I am working currently, we work on open source contribution as well. So some of my colleagues have developed the modules of Terraform, which basically helps on the deployment of the like launching the infra of what you will say RDS, Relation Database System. So earlier there were very less modules available for RDS, but and lots of features were missing from those modules. So they created their own modules and they like uploaded or like committed them on the GitHub, and they are available for public now. So this is how the open source contribution works. And also you can also write the blogs on a particular module. Your blogs may get selected in the organizations, and they may suggest more people to use your module. Like for example, there was a guy, I know a guy who was working on a specific plugin which was related to, I guess, Redis and the Kubernetes. Both are the technologies. So there was some integration between these two technologies, and he was working on that plugin. And he wrote that plugin, and he just hosted, committed that plugin on his GitHub. And he also wrote some few blogs on that particular plugin that he wrote. Now, what happened? Microsoft saw that plugin, and Microsoft thought that this is a very, very great plugin. Like Microsoft has AKS, which is Azure Kubernetes Service, and that plugin was written for the AKS specifically, not for any other cloud platform. And after that, Microsoft picked that plugin and showcased that plugin in the blogs of Microsoft and also in the Microsoft community pages. And they show the name of the developer, they showcase the organization who is maintaining this plugin. And now, whenever somebody wants to do the same work, Microsoft says that you should use this plugin. This is how open source works. Now, this was the open source for the plugin only, but the Microsoft is not, Azure is not open source. Still, Microsoft also supports in this a few points like, yeah, this is a plugin which supports the Azure. This will make people easy to switch to the Azure or to work on the AKS. So that's why they suggest people to use that plugin. This is how open source works. It's a very
Uh,
huge community in the whole world.
Understood. Thank you.
Okay. Now, again, as you can see, Cloud Formation, it is offered by AWS for free. Now, it's for free, but if you are launching the infrastructure, if you are using the more facility of Cloud Formation, then definitely it's chargeable. Okay. Writing code is not chargeable. Rest of the things are chargeable. If you are working with, if you are launching anything which is taking space, which is using resource, that means the Amazon will start charging of you on that particular basis. Now, when it comes to support, HashiCorp offers 24/7 support, and you will never require support in the Terraform, because if you are facing any problem, that means lots of people have already faced that problem. You Google it, you will find it very easily, both for Terraform and CloudFormation. You're not the only one who is facing the issue. So this is a great thing for the tools like Terraform. Basically, Terraform has more. You will find more searches on the Terraform as compared to CloudFormation, because it's only for the AWS and not open source. But still, AWS is a very popular platform. You will find lots of solutions for CloudFormation as well, but not as much as Terraform. When it comes to the state management in Terraform, we have the TF state file basically, which manage the whole states, the whole state which is currently going on with the infra. For example, you deployed the infra, you created three EC2 instances. Now, this information, like these three EC2 instances are launched, will be stored in a file. You can keep that file on anywhere, like usually we keep that on S3. And whenever we are launching the infra or we are doing any modification, first that file is readed that these three instances are already launched, and the changes are done against that. Like if the file says that three instances are currently running, and if you say I want to launch three instances with the same configuration, it will not allow you to launch the instance. It will say these instances are already running. And if somebody has done the manual changes by going on the UI, then after that, if you're again launching the executing the Terraform code, it will revert that change. It will remove those changes which are done from the UI. Because when we are using the infrastructure as a code, that means we are not going to use the UI. The reason of using infrastructure as a code is that let's take the example like why we should use the infrastructure as a code. For example, your task is to launch one server, okay, one database, and okay, like two servers, one database, and one load balancer, like this. So load balancer will be sending traffic to the servers. The servers will be connected to the database. Now, when we talk about the connectivity, what we require VPC, we require subnet, then we require load balancer, security groups, instances, the volumes of instances, the key pair file, lots of things are there, right? But if I say you have, first of all, you created the infrastructure, right? You will take few minutes or a few hours, and you will create the infra. After that, if I say you have to create the exact same infra again, you have to spend same time again. And if I say one more time, you have to create the same infra. Now this is getting difficult for you. Why? Because the task is increasing, and the same task is increasing again and again. So it's very difficult to manage the infra when the number of servers is very high, when the number of resources is very high. So in that situation, there is only one solution, that is infrastructure as a code. In which what you will be doing, you will writing the code once, and by one click you will be launching the infrastructure. So this is the reason why we have infrastructure as a code. If you have written the whole structure of creating the networking from top to end, you can do that with the infrastructure as a code very easily. So this is why we are using infrastructure as a code in the industries. Okay. So whenever you have number of servers increases more than I will say like whenever the number of servers increases more than 20, or as per your requirement like 20 or 30, and you say you want in future you will be going on 100 number of servers, then you should definitely go with the Terraform or CloudFormation to maintain the stack or infra. It's more beneficial with. Now modularity, as I told you, we have lots of modules available in Terraform and lots are under development, you can say. And in CloudFormation, basically, there are no modules. We have features in CloudFormation to launch the resource, but all the things are related to AWS. So that's why we don't have any separate module that can be integrated. And change verification, like in this, we have a plan concept. Whenever you are going to launch, applying the Terraform code or launching the Terraform script, it will ask you before applying the changes. So there is a stage, you can say, which is a planning stage. You can say it's a command called Terraform plan, which will be showing you the number of changes that are going to be applied. And in CloudFormation, they basically it's a change sets which show you about the information which is going to be applied. This is the basic differentiation between the Terraform and the CloudFormation. You guys got it?
Yes.
All right. So now let's talk about the another thing, which is basically it's the Ansible code. Now this is this is the Ansible resource. No, this is how CloudFormation code looks like. Okay, this is the sample of CloudFormation code. And tell me, do you think this is difficult? It's easily understandable, right? Resource, instant node, type, AWS EC2 instance, properties, instance type, T2 micro. This is the image ID that we want to use. You can easily get the image ID from the AMI catalog. Every image has, oh sorry, every image have a specific AMI ID. You can easily get the AMI ID, right? Key name, we are using the DevOps key, which is our public key that we are, not the private key that we are using to log in into the instance, right? The DevOps.prem key. Here the name is CloudFormation. Security group, here you have to provide the security group ID. Simply another instance, and the network configuration is provided here. Now ingress means inbound. Okay, this is a security group, and this is enable SSH and HTTP. Ingress means inbound, and when it is egress, that means outbound. This is how the code looks like. It's very easy to understand, right? And easy to write as well. And basically, this is how Terraform code looks like. Now, it's a very small piece of code. Some we have to create more files as well in Terraform, like tf state file is also created. So again, in Terraform, again, it's very easy to understand. Like provider AWS access key. I guess we should have one more thing here. Okay, so access key, you have to provide the access key, secret key, region, select the region. What you want to do resources, AWS instances, right? Count of instances, 5. You want to launch the 5 instances, type t.micro, AMI, and the AMI ID. Very easy to use the Terraform. But here, let me tell you, for using this AWS instance, you have to create a module, or you have to use the existing module, which is AWS instance, so that you can launch the specific instance or any module where this function is present. So yeah, in Terraform, the number of file will definitely increase. But this is whole cloud formation. By only this cloud formation, you can launch the instance and the security group directly. So this is how the cloud formation works. Okay, so before we do the practical of cloud formation, let me tell you about the Ansible versus Terraform. Now, as I told you, the Terraform is the infrastructure as a code tool, or you can say infrastructure provisioning tool. There's another term which is provisioning here, infrastructure provisioning tool. Both are the automation tools, by the way. But the Terraform is specifically for the provisioning infrastructure, and Ansible is specifically for the configuration. Terraform cannot do configuration as good as Ansible does. And Ansible cannot do the infrastructure provisioning as good as Terraform does. So usually we use the combination of these tools. Sometimes you will be using the CloudFormation here on the place of Terraform. You can compare the Terraform and CloudFormation. Both are similar kind of things. Both are for infrastructure provisioning. But here we are taking the flexible tool Terraform here. So you can compare the Terraform and Ansible as well. Now, when it comes to the infrastructure support, supports immutable infrastructure, supports mutable infrastructure. Now, you guys know about immutable and immutable. Any idea?
I guess mutable means something we can't override. Like, mm, uh,
Anyone else?
uh,
Like
yeah.
Anurag, Adarsh, Vinay. What is the meaning? What is the meaning of mutable here? Anyone? No? All right. So let me tell you. So basically, immutable means the thing which cannot be changed, the state which is static that cannot be changed. That's the immutable. And immutable means that can be changed or by passing some values or something like that. Have you guys watched X-Men movies? In those movies, we have mutants, right? So mutants means they are mutated or they are mutable, basically. They can change their form. So that means mutable. And immutable means humans. Those humans are not immutable. So you can understand it like this. Immutable means that cannot be changed. And when it comes to the overriding, both can be overridden. Okay, Rajeshwari? Immutables can be overridden, but not changed. You cannot change the same object, but you can override that particular object. So remember that. And what overriding means? Overriding means deleting the older one, adding the newer one. So that means replacing means overriding. Changing is not possible. Now, language followed, it follows a declarative language, it follows a procedural language. Basically, just forget about this point of declarative and procedural. Sometimes you use the JSON, sometimes you use the YAML. Most of the cases in Ansible, you will be using YAML. In Terraform, you use the combination of both JSON and YAML. Okay, so yeah, only two languages will be used here, JSON and YAML. Same as it is in CloudFormation, we will be using YAML. Okay, I will show you how YAML code looks like. Packaging and templating. Now, what is the meaning of packaging and templating? Basically, templating is also the same as modules, right? And packages support. Packages is basically a group of module, you can say. So we just got to know like Terraform has lots of modules. So definitely you will have lots of packages in Terraform. Package is nothing but it's a group of module, and every module has few functions. Okay. And when it comes to the Ansible, again in Ansible, we also have Ansible is also open source kind of thing, right? Maintained by Red Hat, basically. You guys know, if you guys don't know, Red Hat currently comes under IBM. Okay, IBM owns Red Hat, and Ansible is the product of Red Hat. Red Hat is the organization who also has a open source version of Red Hat Enterprise Linux, and that open source version is known as CentOS. Okay, that's the Linux operating system basically. So Ansible is developed by Red Hat. It's basically more good on the what I will say Linux systems. Ansible is a good tool for the Linux systems. Terraform can work on Linux and Windows both, because Terraform works great with the Azure as well. So it can work on Windows and Linux both. But when it comes to the Ansible, Ansible is a good tool for Linux only. In Windows, you have to struggle a lot to work with the Ansible. You have to struggle because the core of the Ansible is to use the Open SSH. That's a tool. Open SSH is a tool that we use to, like, Open SSH is nothing but it's the SSH. Ansible requires the SSH connection to do its work. And the case is not same with the Terraform, because Terraform directly requires the credentials so that it can launch the infra on the public cloud. Now, when it comes to the state and lifecycle management, and Terraform is heavily dependent on the state and lifecycle management. Heavily dependent means, as I told you, in Terraform we have a TF state file or state file which contains the state of the current state of the infra. If you have launched the Terraform code, the state file will be generated, and the state file will contain the current state information of the infra. The case
What
is
is
different.
state file?
State file is like, for example, I'm launching servers, right, using Terraform. I launched 5 servers. Now that state file knows that the 5 servers are launched in this AWS account. Now, if I run the same Terraform code, the state file will directly give me the error or the output that these servers already exist. And if somebody does the change in any change in the networking, any change in the networking, and if I apply the Terraform code again, the networking change will be reverted, because the change which is mentioned in my state file, that will be applied. So state file manages the state of the infrastructure. That's why it is recommended, if you are using Terraform with your infra, that means your whole infra is going to be managed by Terraform. So never do the UI changes after that. Even if you want to open the port in your security group, you cannot do that from the UI. If you do it from the UI and if somebody executes the Terraform code, then your changes will be reverted. The opening ports which are mentioned in the code will be applied.
So the UI always overcomes the code.
Exactly,
Is that what you're saying? Okay,
exactly. So, like, no, code comes over the UI. Like, code is most priority. Code is the priority. The
okay,
code will override the UI changes. So that's why we
understood.
call it immutable here. Now, Ansible is not like that. There is no state file in Ansible. You can do whatever you want to do. Ansible doesn't care what's happening with the server. If you want to install something, if that thing is already present in the server, Ansible will say, yeah, this is present in the server. So I won't be doing that again. That's it. It will be showing you the output like changes 0, changes 1, like this, if something is done over there. So this is how Ansible works. I guess you guys got the whole concept, all difference between the Terraform and Ansible. We will talk about Ansible more. We'll be doing the practical of Ansible. Before doing the practical of Ansible, let's do the practical of CloudFormation. For practical of Terraform, you guys first have to go through the Terraform concept. You guys have to go through the documentation from the Terraform, and there are lots of modules that you guys have to go. And CloudFormation is very easy. We will go through the CloudFormation. It's a very easy concept. We'll do that. So let's start with the CloudFormation. No need of these images now. Let me close the images. All right. So here I have few files here. Okay, I have already copied the code for the CloudFormation. So what I'm going to use here is very popular text editor, that is VS Code. It's a great tool to write your code, whatever language you're using, doesn't matter. It's a great tool to write in code. Okay, so I'm not going to use the this is basically the Ansible code. Okay, this is how it looks. I will tell you about this later. Right now, we are going to talk about this CloudFormation code, and let me explain you this code. The code is very easy to understand. First of all, resources. In the resources, we have EC2 instance. That means we are going to launch the EC2 instance. Okay. The type here is AWS EC2 instance. This is the type of the instance. Then we have properties here. In the properties, the ID is mentioned. This ID is for the Amazon Linux server. From where you can get the ID, just go to the Amazon AWS, right? This is AWS. Go to the EC2. In the EC2, we have AMI catalog here. Click here in the AMI catalog. And here you have the AMIs, right? And this is the AMI ID. 1 8 in the ending, right? This is the AMI ID. If you go here, 63 is here. Let me check. 63 is maybe some other ID. Like, let me place the ID. Let's see. The image is, so you can search for the ID as well. Here, hit enter. You'll get the AMIs here. Okay, so it says no AMI with the ID. Why? 63. I know, like I picked the ID from the server. Maybe there was some ID with the same thing, and it actually should show the ID. Let me check the ID again. Loading results showing 1 of 50. Okay, lots of results are here, not picking up the ID directly. So what we can do here is we can launch one instance and we will do select the ID, right? So what I did over there, I just selected this instance. Okay, just select one instance, launch instance with the AMI, and you will find the exact ID here. Uh, and here it is. As you can see, this is the ID, right? And if I place the ID here, search the ID here, it should give me sessions, right? Okay, it's going back over there. Maybe there is something which is changed with the server. That's why ID is changed, because ID only changes when there is some change gone on that particular image. The ID is created along with the image. Maybe there are some changes done. I selected this one or this one. I don't know. Like, let me select this one. Launch instance. Let's see if the ID is same for this server or not. It's 23D. It's 63. All right, no issues. You can pick any ID. So what I'm going to do is I'm going to pick any of the IDs. So I'm going to select the first one, or I guess we should select the Ubuntu instance, right? We are working on Ubuntu from a very long time. Also, the Ansible code that I'm going to use is basically for the Ubuntu. By the way, we are going to delete the instance after the launching it through the, sorry, cloud formation. I'm not going to launch the instance. I'm just going to collect the ID. From here, I can copy the ID basically. I can select and copy the ID easily. That's why I got here. So here you can replace the ID, and I replace the ID. So earlier the ID was this and I placed this ID. So the instance will be launching here. That will be the, what we will say, Ubuntu instance. Okay. This is the instance type. Very easy to understand. Subnet ID. Now subnet ID will be same definitely, because subnet is created by us, that comes in the networking. So if you just go here and click here, I'm just showing, comparing it from the launch configuration, like here where we are launching the system, but you can compare it with the direct from the VPC section where you will see the subnet IDs. Okay, so if you just paste the ID here, hit enter, again it says no preference. Okay, let me just check. Oh man, that's why I didn't got the same ID. You guys can see the region was wrong. The instance ID, oh sorry, the subnet ID was not even matching. Now you will see the exact ID, as you can see, the 63 in the ending, right? If I just do Control Z here, the 63 in the ending, that's the Amazon Linux ID. It's matching here. Why? Because the region was changed and we were in the Mumbai region, because and I picked the ID from the North Virginia. So always remember that the region matters. Okay. And here, as you can see, subnet ID 27 in the ending and 27 in the ending, right? This is also same. When it comes to the security group, I have selected the default security group. If you click on the default, you can see CD in the ending. And no, this is not the default one. Okay, this is not the secure. Yes, are you saying something?
Yes, so this Terraform code is not replicable in different regions. So for every region, you need to write a different Terraform code,
No, no,
right?
no, 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 no. Basically, we are
Okay.
not using the Terraform code. Firstly, we are going using the cloud formation. Okay.
Oh, sorry, CloudFormation.
Yeah. And cloud formation is basically in which region you are going to launch the resource. So you have to provide the resource information of that particular region.
Okay,
Okay. So if I'm launching the resource in a region, so I have to give the information of that particular region. Okay.
understood.
So here, as you can see, this is the security group ID. Okay. 6E in the ending, 6E in the ending, right? And this is our key name. If you want to find the key, here is the key pair. This is the key name, right? The same information is provided here. Just cancel this. We are not going to launch the instance from here. Now let's talk about the YAML mode. Now remember that in YAML, spaces are the most important thing. If you just did this, the whole YAML is incorrect. You cannot apply this in the Terraform cloud formation. So spaces are very important thing. So to validate your YAML, what you can do is copy your YAML code, and there is a site called YAML validator. Just search for that, open the YAML validator, paste your data here. Now it says valid YAML. If you do any wrong change, it will say error. Now it will also show you the error place where the error occurs. Okay. So always remember that you should keep your YAML validated. Otherwise, it will not be executed on AWS CloudFormation. Even if there is any error in your YAML, CloudFormation will not allow you to apply this YAML. Okay, so this is very important. Now let's go to the AWS Management Console. Here we have the service of CloudFormation. Here it is.
Manish, sorry, I will interrupt you here once. I want to go a little bit back because my confusion is we are writing CloudFormation, which is for provisioning the resources, but
Exactly.
YAML is for writing configuration, but you
Yeah.
said
No, no, no,
Ansible
no.
is for
Look,
writing.
look, 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 look. For example, YAML is nothing but it's a markup language.
Okay,
Okay, it's a markup language. Like when we talk about the JSON and YAML, these are the languages that we can use in multiple things. Multiple tools supports these language. Even in Kubernetes, you're going to write the YAML. So YAML is
okay,
not only for what you will say Ansible, or not only for cloud formation, or not only for Kubernetes. Maybe in future there are more tools that are introduced and YAML will also work there. So it's just a markup language, or you can say, and when it comes to JSON, there are like serialization forms, data serializing, like serializing data in an understandable manner, you can say. The way, the language which can be understood by person and as well as system as well. So not directly system understands the YAML, but yeah, system can parse the YAML. System can read the YAML. System can divide the YAML in key value pairs in the form of instruction. Then the system can understand what the should be done. Okay, that's why we write the code in the YAML. Okay.
understood. And can you just touch base again about the difference between configuration and the Terraform thing? Like, I know you explained it, but I'm still a little confused, like,
Okay. Look,
because I find it very similar. Yeah.
when it comes to the infrastructure provisioning tools, those tools will be launching infra. They will be working on the infra. And working on infra means opening ports in security group, launching the instances, launching the load balancers, launching the database servers. When it comes to the configuration management tool works on the OS level, operating system level. They will require the login inside the instance. Then they will start their work. And their work will be installing the softwares, doing deployments, changing configuration files inside the server, not outside the server. Infrastructure management directly works with the cloud, directly interacts with the cloud platform. Configuration management only works with the system, not with the cloud platform. This is the major difference.
Now I completely understand. Thank you.
Now, here we have the service of CloudFormation. You guys can search it from here as well. Let's click on the CloudFormation here. Now, here we have the option of create a stack. Just click here, create a stack. Now, template is ready. User template or create template in designer. So yeah, it provides you a designer way to create your own template, but I will suggest you to use this template is ready. Upload the template, choose the file from here and upload the file. So file name is this, EC2 CloudFormation, open. Now, as you can see, the file is going to be placed in a S3 URL, right? S3 bucket. So remember that if we delete this stack, after that we have to delete this S3 bucket as well, if it is present over there. Click on next. If there was any error, this page will never come up. Now, this page is here because it's asking for the stack details. That means there is no error. And after this, we have to give the name of the stack. So EC2 hyphen test. Just after this, click on next. Now, as you know, in AWS, you cannot work on and communicate with any other service without the permission, right? Every service requires a special permission to communicate with another service. For example, you guys remember when I wanted to use the S3 inside the instance, what I have to do? I have to apply one role. That was the IAM role. Similarly, if we want to launch the instances, sorry, using CloudFormation, then we should have one IAM role here. Without the IAM role, we cannot use the CloudFormation or launch the instances. Why? Because in our CloudFormation code, it is written that launch the instance. And CloudFormation is a separate service. EC2 is a separate service. So to doing this automation, we have to create a role and attach one policy so that the CloudFormation can create the EC2 instance. So I'm again going to the AWS Management Console. Here we are selecting IAM. In the IAM section, we are going to create one role. So here, as you can see, we have the option of roles. Let's click on the roles, create role, AWS service, go here, type CloudFormation. As you can see, this is the CloudFormation. Select this CloudFormation, go to next. Here you have to attach the policy, search for EC2, hit enter. Now, as you can see, we have Amazon EC2 full access policy here. Select this policy, scroll down, click on next. Here you have to provide the name for the role, Cloud Formation Role. Scroll down, create role. As you can see, role is being created. We have redesigned the IAM role experience. What it says, I want to create the role. Okay, now it's creating the role. Creating role for CloudFormation, and that's it. The role is created. As you can see, CloudFormation role is written here. Go back here, search for the role. If it is present here, click on ARN, again click on this IAM role. Still, we don't have output here. What we can do here is let's try to copy this role and paste it here. Let's see if it can pick up. No, it's not working. So what we have to do, we have to refresh the page basically. No other option. So let's refresh the page. And when we will refresh the page, it will go back and create stack section. So again, we need to upload the file, choose file, EC2 CloudFormation, click on next. Again, stack name, EC2 hyphen test, next, IAM role. If you click here, now you will see the CloudFormation role here. Only role who has the power to launch the EC2 and the role which is created for CloudFormation, basically only role which has the power of, which is created for CloudFormation will be listed here. So this role was created for CloudFormation. That's why we are seeing this role here. There's no other role for CloudFormation. Just click here. Go back, scroll down, click on next. There are lot more options. You guys can check that options easily. Nothing special. There are few SNS options and etc etc. As you can see, this is going to be created, right? Create in progress. Okay, if you just refresh here, more services are created. More refresh, and if you want to see the outputs, you can click here. By the way, there is no output here right now. Click on the template. This was the template that we applied here, change set. Right now, there is no change set. We can create the change set basically, which is basically nothing but it's a kind of state maintaining that we do in Terraform, similar kind of stuff. We can manage the state. Change state means if somebody does the change from here, that can be overridden and we can record the changes as well. So in the resources, as you can see, this is going to be the instance ID, which is going to be created. Okay. By the way, there was no instance available till now. Let's go to the EC2 instances, and you guys will see the instance is being launched, or maybe it's launched. Okay, so this is instance is launched right now. Let's click here, and you can compare the time. 5 December 21:56. Right now 9:57. So the time is correct. Okay. So this is how the instance gets launched using the AWS CloudFormation. Now, if you go here in the events, if you just refresh this, it will say create completed, right? The instance has been created. You can see the instance here, right? Any doubts in CloudFormation? We just applied it and the instance is created now.
No doubts.
All right. So now if you want to delete this CloudFormation instance, what you have to do, just click here, stack, and uh, yeah, here it is, delete button, right? Just delete stack from here. That's it. Now, if you go here and refresh the instance, it's shutting down. The instance will be terminated automatically. Why? Because we are deleting the stack. So this is the power of CloudFormation. If we have created the instance from the CloudFormation, it will be deleted when we will be deleting the stack as well. Okay. Now this instance will be deleted automatically, and you can delete the whole infra that you have created using the CloudFormation, right? So it's a good thing to practice as well. So no worries to remind that what you have created and what should be deleted or not. Okay. That can be done easily from here. If you just do the refresh, delete complete, stack info, delete complete. Cloud formation, no stack is available here. If you go here, do refresh, the instance is terminated now. The instance is automatically deleted. This is how cloud formation works. Now let's talk about the configuration management tool, which is nothing but it's Ansible. So now Ansible is basically for configuration management. That means we will be installing this time using Ansible, we will be installing the Nginx. Okay. So by using this simple Ansible playbook, now we call them playbook. In Ansible, we have playbooks. Okay. So here we have the host entry, task entry, the name of task that we want to do. Here is the module basically for APT that we are using here. That means name Nginx state latest. If we want to put any version here, we can do that as well. By default, it will be installing latest Nginx. APT command, you guys remember that we use in the Ubuntu systems, right? Debian systems. Now here, name start Nginx, service Nginx start. Now this is the command that we have used multiple times, like service Nginx start to start the Nginx server. Now there are multiple things. You guys can run this on directly on the server, on any server. But for that, we have to launch the instance. So let me do that very quickly so that I can give you the direct brief on the instance. I'm launching one Ubuntu instance because we are using Ubuntu here, right? And let me search for the Ubuntu images. Where it is. If you are looking for the free tier eligible, and it shows like the whole images. Let me scroll down. We will find Ubuntu free tier available here. Okay, so I'm launching one Ubuntu 20.04 server. Selected. Just scroll down, keep here DevOps.pam, edit configuration, enable the auto assign public IP, select the security group. Security group should be default. Okay. The rest of the things are same as it is. Just launch the server. Server is being launched. Let's go to the machine, right? I'm going to use the master machine as my own system, the virtual machine, which is present in this virtual VMware. Now, what is the meaning of master? Like in Ansible, what we have to do, we have must have a controller machine. Why controller? Because you will be executing the script from the controller, and that script will be executing on a remote server, on a different server. This is how Ansible works. Similarly, the same concepts works with the Terraform. We run the Terraform script on our own system or any server, and the impact is on done on the public cloud. But on cloud formation, you have to upload the template file or your template over the AWS. So these are the differences. Remember that. Okay. So here, as you can see, the system is on. Let me just check the system. No, I don't want to upgrade. ifconfig. Let me check the IP address. So right now, yeah, this is the IP address available here. 29.95. All right. Sudo su. Let me go to the root. sh 192. Let me try something. Do I have 29.95? Okay. Now I am inside my this virtual machine. Okay. So the instance is launched now. This is the instance. Okay. And what I want to do is I want to first of all need the IP address. Here I have one folder and the folder is okay. The files are outside the folder. So as you can see, nginx.yaml is already available here. Okay, nginx.yaml is already available here. This is the same YAML, right? That we saw in the desktop. It's the same YAML. I've already placed the YAML here. And if I just go back, here we have one more file, that's the inventory file. Now, in inventory file, you have to provide the IP address of remote servers. Now, here I provided the IP address of my own system, which is 27.0.0.1, which is the local system. And here we have to provide the name, which will be Ubuntu, right? Like this. By the way, name is not important. We are just creating an inventory file. In inventory file, you can also add multiple servers. What will happen then? In every server, the Nginx will be installed. You can do the same configuration on multiple servers. That is the power of automation. So to install one server using Nginx is a very bad thing, right? It's not a good idea. But when you want to do the same thing with hundreds of servers, then Ansible is a great thing. You just have to set up the SH, and what you have to do is just have to use this inventory file. After just using this inventory, you can directly do the installation on multiple servers. So I took the this file. Okay. Now, secondly, what I have to do is I have to configure the SH, and the SH should be direct SH. There should be no password over there. So I'm not going to take the SH directly from the system. I'm just opening this in a console, the UI console, and I'm going to paste the public SH key directly in the server. So this basically it's not nothing but I'm just setting up a password-less SSH authentication so that this server could be managed directly by the Ansible master. Okay, so sudo su so that I can go to the root. After getting into the root, what we have to do is we have to go to uh, cd.sh. Before we do that, let's open the vim shd underscore config. Okay. Inside this config file, we have to turn on few things. Number one is the authentication method. Okay. So first of all, it's the permit root login. Just disable that. We want to enable the root login. By the way, remember that this is not recommended if you are using a public IP server. The server can be hacked very easily. Okay. But I'm enabling that because we have to do the testing and we want to use the root user here. Strict mode, basically it's yes, and max authorized. Also, one more thing should be enabled. That's the password authentication. I want to do that yes as well. Okay, this is also yes, and that's it. Just save the file. After saving the file, service SHD. which is the SH service, and restart the service. Okay, service SHD restart. That's it. The SSD service has been restarted. The second thing we have to do is we have to set up the SSH key. Okay, so cd.sh, here you will see few files. As you can see, there is a file of authorized keys. Just open this authorized key file. This file already contains one SSH key, and that key is nothing but it's the key of the same system. Okay, now what we have to do, we have to paste one key here, and that key should be the key of this master. So from where you can find the key, I have already created the key idrsa.pub. Get this key, and this is the public key of this system. Let me copy the key here. Let's paste it here. Control Shift V, and done. Okay, master. And what we have to do, we have to do few changes here as well. Like as you can see, 200 is also written over there. We have to remove that. Let me do escape here. Okay, the SSH-RS should be there. That's it. Let's save this, and we are good to go. Now what we will do, we will just use the IP address and try to do the SSH here. How? SSH, the IP address, not here, on the local system. SSH and the IP address. Hit enter. We should be able to do the SSH. Yes. And yes, we are good to go. As you can see, I directly took the SSH to the remote server, right? So you should set up a password-less SSH authentication so that Ansible could work properly. That's it. Our work is done from here. I'm exiting from the server. Now we have the Ansible playbook. Let me show you the playbook, not from here, nginx.yaml. This is the YAML playbook, okay? And the steps are same as it is, the apt, nginx install, and restart the nginx server. But before we do that, that server is a fresh server, so apt-get update is required, right? It is necessary. I forget to put that in the Ansible, like this is necessary, because if we don't use this apt-get update, it won't be able to, it may not able to install the nginx. That's it. The apt repositories are flashed up. Let's try the Ansible now. So the command is very simple, Ansible -playbook. Okay. After this -i, and you have to give the inventory file where you have mentioned your all hosts. Then you have to give the YAML file and hit enter. That's it. Play all gathering task, gathering facts. It will start work on it. As you can see, okay, first it tries to connect connection. Okay, this is the connection tested. It means gathering facts. Okay, the connections are on the left, things are tested. Now nginx installation has been started. Once the installation is done, as you can see, changed. That means installation is done over there. Now starting nginx. As you can see, that's it. OK 3 changed 0, unreachable 0, failed 0, script 0. This is how Ansible gives the output. And if you go to the server, right, you remember the public IP? Let me check. Let me copy the public IP. Let's just test the public IP directly. Hit enter. Nginx is working, right? This is how Ansible works. Nginx is working, and if you go here, you will see the Nginx has done the installation as well. You guys got it? You guys got it? This is how Ansible works. You can directly do the automation by just using few lines of code. That's it. If you guys have any doubts, you can ask. Anyone?
So the The process is first we will provision using CloudFormation or Terraform, and once it is available, so for CloudFormation, you showed us that we have a stack, but when we
Exactly.
use Terraform, we will also.
In infra, like if you are launching or if you are setting up whole infra, the setup is called stack, where you have multiple servers, the connectivity, lots of stuff is going there. That's a stack. That's a term basically. But in AWS, it calls the service as a stack as well. Like in CloudFormation, it shows the name as a stack.
Okay.
Okay, yeah, that's the thing.
And then when we write the code in Ansible, it can be applied for the whole uh, infrastructure which we created. Like if we have multiple servers, we can install Nginx on all of them, right?
Exactly. But remember that
Okay,
you launched the infra for once, but you may need the configuration multiple times, right? For different
right.
types of work. So it just depends on the use case. For example,
Okay,
somebody says you have to set up 100 servers of Ansible, sorry, of Nginx. If you know Terraform, or if you know CloudFormation and Ansible, you can do that in hours or in minutes, basically, not in hours. You can do that in minutes, right? Because it's very
right.
easy. You just have to apply and you just have to run the Ansible playbook. That's it. Your work is done. So
So the code which you wrote, that is called a playbook.
yeah, in Ansible, this is called a
Okay,
playbook.
okay.
Okay. So guys, that's all for today. If anyone still has the doubt, you can ask. Let me stop the